The final statement in this homework is to do a repeated measure analysis of variance with two factors. So let me highlight that again. We'll make this in blue. Okay, so a repeated measure analysis of variance with two factors, one between group, one within factor. This is a more advanced statistic. We have now basically accounted for all components of the analysis. So we have to meet certain assumptions. So let me go back to our statistical assumptions. So for a parametric analysis, whether it be a t-test or an ANOVA, we have to meet these basic assumptions. We need numeric data, ratio or interval, like strength. We need to have a random sample that's somewhat organized and represented by trying to get people to randomly be in your study. A lot of times it's a sample of convenience for some of these research projects that you can't get a very large sample. We've already talked about normal distribution, but the other component, which is critical when you do an analysis of variance, is the homogeneity of variance. That basically means, is the variance of the groups equal? So do we have equal variance or equal standard deviations? And so when you run a repeated measure analysis of variance, it's a little bit more involved and maybe perceived as confounding, but the beauty of that is it takes all components in together. Again, it only works when you can do parametric analysis. But one thing that I want to sort of set up in your mind of how you want to consider doing a repeated measures is that you have two factors. This is the between factor. So the two groups, healthy and injured, are separate entities. So we have a group of, we have criteria to be considered healthy, criteria to be considered injured. But the within, not the within, sorry, but the within factor is the repeated analysis. So we do the same strength measurements at the beginning as we do at the end. So that's the within factor. So every group, every person in both groups, both the healthy and the injured, are going to have a value and a variance at baseline, and then that same test will be repeated post-intervention after 3 weeks of training, and then they will have the same analysis performed. So you can see this group, this line, is one group of the between factors, where the other, the injured, is a separate group of people. And that's why it's considered a between group factor. But in both cases, the same assessment, pre and post, and if you had multiple posts, if you had 1 month later or 6 months later, you would have more measurements. You could have as many within factors as you needed for your design. But this is a relatively straightforward and simple. And in this case, the analysis of variance is going to look at both groups simultaneously. So that means we're going to have to manipulate the data. Instead of doing them as separate analysis, we want them compared. We want to do the analysis with both groups considered. Again, you'll have to run an analysis of variance, a normality distribution to see if that's possible. But even if it isn't, I want you to still run it so that you have the experience of doing that. Okay, so back to our data. We need to turn off our split data. So we no longer want the data split. We want everything considered together, because in our repeated measures model, we're going to have both the healthy and the injured together in the baseline and the post-test all in one model. Okay, so we go to analyze. The repeated measure is considered a general linear model, and it's a repeated measures design. So when you get this, you're going to get this little variable that pops up, and it's going to have within subjects. This says factor 1. It defaults to always saying factor 1, but you can make it mean something to you. So in this case, I'm going to call it time because we have 2 time points, baseline and post-intervention, and I have to know how many levels am I going to analyze. If I'm going to do it in this example, I'm going to have 2 data points. So I hit that add, and that's all I have to put on this menu. So now we're going to define those 2 time points. The second factor, the between factor, is going to show up in this measurement menu, and here you can see the between subject. So in this case, we're going to use group. So that's our healthy and injured, my 3s and 2s. And then I'm going to have the 2 time points. Again, I'm going to use the same data points that I've been using for everything else. So here's my upper trap average strength baseline or pre, and compare that to my post. Here's my upper trapezius average post. Now, in this case, because you haven't done much of this data yet, I want you to graph this out so you get an appreciation of what is actually happening. So you have 2 separate lines and a horizontal axis. So it makes the most sense to have pre and post as your horizontal axis. That'll be time. And then your 2 groups will be the 2 separate lines. And if there's an interaction, you'd expect them not to be parallel. You'd expect one to go up. In this case, we've seen this data a couple times now, so we know in our heart that strength is going to increase more in the injured than in the healthy. So our graph should show this interaction effect. So we put those in, then you have to hit add for it to actually tell the computer program to run that analysis. We hit continue, and then we go over here to our options, and this is an important step so you get your means and your standard deviations at each step. Now with a repeated measures, you have 3 ANOVAs that are being run. You have 2 main effects and 1 interaction. So the main effects are group. Regardless of time, is there a difference between group? And then time, regardless of group, is there a difference between time? Now, the interaction is the combination, and what you're really looking for in this analysis is group by time. So what you're hoping to see, right, as we hypothesize that the injured group would have a bigger, that the exercise would have a bigger effect on the injured group than on the healthy, and that's the most important analysis. So as you've learned in statistics, or you will learn in statistics, when you run a factorial analysis, which this is a mixed model or mixed analysis of variance, or in this case a repeated measures, there's different terms, the interaction is the most important effect, and if that is not significant, then you can try to interpret the main effects. But if the interaction is significant, then you don't try to interpret the main effects because there's a relationship of group by time. I'm still going to ask it to compare main effects. There are different confidence interval adjustments or post hoc analyses. You can do a least significant difference, which is basically a paired t-test, which really doesn't correct for anything. A Bonferroni is the most stringent one, so it is probably the most conservative. And then SIDAC, I think, was the third option. I typically do a Bonferroni. That's just my bias, but each of you might learn different techniques in different ways. There are multiple post hoc analyses that can be run, but these are the common ones that are offered in SPSS. We can also do descriptive test. We can run a whole bunch of other analyses, but let's keep it simple at the beginning and sort of see if we can interpret that. There is one additional analysis that we can run. We'll see if we have a significant interaction, and I'll rerun this and show you what I would add to look for post hoc for interaction effects. Okay, so we've got our repeated measures. These are within factors, pre and post. We have our between factors, so now we're ready to hit OK. and then actually running the statistics takes very few seconds. So we have our 14 and 9 subjects. We have our descriptive statistics. And if you go back and you sort of, without even looking at the p-values and stuff, we just go back and we drop this in next to these values. And we just sort of look at what's going on, so I can sort of get a sense of exactly what's going on. So in my healthy group, I've got 21 and a standard deviation of 9. So you can tell I'm not too worried about decimal points. We're just measuring strength here. That's our healthy. The injured group starts at 14. If you feel you need to add a decimal point, feel free to. I don't typically worry about that. And then standard deviation of 4. So you can sort of see at the beginning, as you would expect, injured patients are weaker than healthy patients. But after the training, so now if we look at post, here's our healthy. Now there again, 21 plus or minus 8. They didn't really get all that much stronger. But did the injured group, that's who we're most interested in, and they're 20 and 4.7. So we go 20.8 if we'd like to, plus or minus 4 or 4.7. So without even looking at the analysis, I can't type, there we go. I get a sense that I'm going to see a flat line between my healthy, but my injured group is going to go up. So I sort of suspect that I'm going to have an interaction with that. So the next thing that I look at is the graph, to see if my brain is sort of making sense with that. So to get down to the graph, you have to sort of follow down the left side. It's always at the bottom, down in your profile plots. And sure enough, we see the injured weaker than the healthy, but after this exercise program, they get close to about the same. So we definitely do not have parallel lines here. So when I go to read and interpret my analysis, I expect to see an interaction as the main finding. Okay, so let's pop back up here to our descriptive statistics. It gives you a multivariate analysis, which can be interpreted, but I typically skip over that when I'm explaining this to students. And the next thing I'm looking at is Moltke's test of sphericity. And this is a measure of the homogeneity of variance. And if you have equal variance between your groups, you should see that this significance is this dot. And this dot basically means that the null hypothesis is met. If you see a value there and it's above 0.05, you can also assume that homogeneity of variance or the variance is considered equal. But if the value is below 0.05, like a 0.01 or a 0.02, then you might have to use a correction. And SPSS automatically gives you one of 3 corrections. Talk to your local statistician. Dr. Bush has always recommended to me, when I've asked her about this, is to use the Hunt-Felt correction. But when they're all 1, what that basically is saying is no correction is needed. And if you look down here at the analysis, this is the within subject effect, the main effect for time, sphericity assume, and then with all the corrections, all the values are identical. So, because this is a dot, and these are all 1, we get to assume sphericity. Now, if we look at this, this is the main effect for time, but what I'm most interested in is this value right here, this time by group. So we're going to assume sphericity, and we're going to look over here, and our significance is so close, but not significant. So even with that big effect, because my n is probably so small, I don't see a significant interaction with this test. So I've already copied over my p-value, or I'm sorry, my descriptive statistics, but I'm going to bring this over so I can interpret this data. That's the second part of this analysis that I want you to do for your homework, is I want to interpret these values. So it gets a little messy and noisy, so you got to be careful. Make sure you're looking at what you want to look at with this data. Whoa, that's a little big. Sorry about that. There we go. And so I always highlight what's most relevant to me, that I'm looking at those data points. And if you've gone through statistics, you know that the error effect is incorporated into the F-score. I'm not going to go into interpreting an ANOVA table. That's for your statistics class. But basically, you have to have the error score and the calculation for mean squares to get the F values. But you can see in both of these cases, we're just off, right? So if I had 10 or 12 people and had the same phenomena, if I had 10 or 12 people in my injured, I probably would have met a parametric evaluation and I would have been right at significance. So I'm definitely trending toward significance, but by the letter of the law, it's not at 0.05, therefore it's not significant. Now our main effect for time is also not significant. So regardless of the group, if you average those two data points together, and let's go back up here to this analysis. So what it's doing, if you keep this straight in your brain, that it's ignoring the groups and it's looking at the times of the two groups. So this is the baseline or the average of 21 and 14. And then again, at the end of, at the end of treatment intervention, it goes from 18 to 20. So it improved, but did it improve significantly? And the answer is no, not officially. It's only at 0.055. So the only other thing to compare would be the main effect for group. Was there a difference? Regardless of the two times, as a difference between group 1 versus group 2, or healthy versus injured. So we go back to our SPSS, our output information, and now we look at our tests between subjects. Copy. We'll bring that back over to Excel just for interpretation. Makes it easier to sort of see. All right. So don't look at the intercept. Everybody looks at this. This is always significant. You have to look at the group effect. So what we're looking for here, is there a difference between our groups at between healthy and injured. And so this is taking the average of the two groups. So if time, so I'm just going to use this for an example real quick. Time would be the average here of 18 and 20. Group is going to be the average of the rows. So 21 and 21 is 21. And this 14 and 20, halfway between that is around 17 points. 17 pounds, I should say. So it's analyzing between groups, is this significantly different regardless of the two time points? And the answer to that is no. So we trended toward an interaction, but in reality, we did not find a significant difference between group. We did not find a significant difference between time. Again, this is one of the problems with having smaller n's, that we didn't see the effect. So we cannot reject the null. This could be, based on looking at some of this other data, an issue because we've analyzed the data individually and we're seeing something affect. But again, this is why you have to look at that. I just wanted you to have this experience in interpreting that data. So if we go back to the homework, you're going to run a repeated measures analysis, disregarding whatever you found in step A about your normal distribution. You're going to share your descriptive data. You can determine if there's an assumption of homogeneity of variance when interpreting the results. You can write it down, or you can copy and paste it over and refer to that. And then identify what's going on with your interaction, your main effect for time, your main effect for group. And then I want you to write in an interpretation of that Be sure to keep the original hypothesis in your mind, right? So as you go back to this, you can look and say, we hypothesized that this would occur, and we reject that hypothesis based on what we found, that there wasn't a significant difference based on a 0.05 value. So all of that information is going to be put in to your interpretation. And then what I'd like you to do is to create a graph in Excel for your two groups at both pre and post scores. You can use a line graph that would complement what you saw in SPSS. So if I'm going to do that in Excel, so I would write my interpretation down here. Oop. Good if you can spell, Tim. And then what I would actually recommend you doing is I'm going to get rid of some of this garbage here and garbage here. And what I actually have found that works really well is that I actually create two little tables. So one is my mean, and then I repeat that table again, and this is my standard deviation. So I'm going to put my value 9, 8, 4, and 4.7. So I'm going to modify these because it doesn't graph with 2 bits of data in that analysis. So making a table and making a graph definitely requires modification of your data. Okay. So those are my main data points. So I asked you to create a line graph. So if I go over here, this gives you recommended charts, but in this little example, I know this is a line graph, and I want it with little markers. So you can sort of see the same, not on the same scale, but in a similar scale, it gives me that graph information of my means and standard deviations, and you can sort of see that effect. I'm going to move that down here for just 1 second. And so now I can actually categorize that information and give it headings and those components. So the blue was the healthy group. So you can sort of see here it defaulted to Series 1 and Series 2. If I click on this and I go up here to my format, I lied, it's in your design, select data, there are my defaults to my series. So here is Series 1, and I want to edit that. So I want to give it a heading. I can go healthy, hit OK. Now it's called healthy. My red series, I can click here. Now I can type that, but say I have a long heading. I can just highlight the cell that the word is, and it gives me exactly the same information. So there's my basic line graph. Any good statistician is going to tell you you need to show your variance, so we have to add error bars around that. We also should label our information, right? So if I want to go up here and I wanted to edit this, this really is pre and post instead of 1 and 2. Now I got pre and post data. And then I need to give my y-axis a value. I need to actually tell you what I'm measuring. What does 0, 5, 10, 25 represent? So I go over here to my add element, and I want to give the vertical axis a title. So I'm going to say this is upper trapezius strength in, and then usually our units, pounds, kilograms, newtons, whatever is in parentheses and described right there. So now I've got my chart. I don't have a title, but this would be my upper trapezius strength pre to post values in by groups. And I might be more detailed, but that's certainly generic and explains what's going on with that. In my instructions, I asked you to make a separate Excel spreadsheet. So all the analysis is going to be here, all the write-up would be on the same one, and then the Excel, you can just copy and paste that over there. Make sure you hit all of these informations. I've shown you how to do everything except for the error bars. So different colors, different markers. I haven't showed you the markers. Title, horizontal axis, vertical axis, labeled with units, that was pounds. The legend defaulted coming up. You can move where the legend goes, and now I need to show you error bars. So to change the different markers, let me show you that in Excel real quick. So right now they're both little circles. So let's say I want to make one an open square or something like that. I want to modify that document. So I click on that, and then I'm going to right click on the red line, which represents the injured. You can sort of see up in the left hand side, it sort of highlights where it's pulling that data, and I want to format that data series. And so that information pops up on my screen that it allows me to make some modifications here. And what I want to do is I want to modify the marker. So there's the marker. These are my marker options. It defaults to like a little solid red circle, and then I want to modify it. So I have to click on built in. So now it gives me a variety of types. So now let's say I want to make that a square, but I don't want it to fill, right? So I want it to be open. So I click on no fill, and I can change the font size. I can make it a little bigger, and voila, I've built my two different marker type charts. Okay. Last thing is to put your error bars, and this is why I create two different tables, one with means, one with standard deviations. I understand Prisma and other graphing products might give you different ways of doing that. So I click on my healthy, excuse me. I'm going to go up here to my design, and I'm going to add my chart element. So I go design, add chart element, and then down here it's going to say error bars. So it defaults to none, but it gives you other variations. If you click on one of those, it's just going to give you some random value. You actually want to put in the value that you got, which was for our group 9 and 8. So we want to go down to more error bar options. That opens this menu on the other side. Typically you go above and below, +9 and -9. That's what the standard deviation is. And so when it asks you, this is a fixed value. If you got lucky and they were both 9, theoretically you could put that in there. That never works for me. But custom, I get to specify the value. So when I click on that, it's basically asking me to put the values in here. So if you click on the little icon and you highlight the healthy, that draws the upper part of the bar, and it automatically defaults this to a -1. So I just highlight the exact same data, and it'll build the lower part of the bar. And so now you can sort of see the standard deviation. And when you add the standard deviation, you really get to sort of appreciate why we might not have seen as much of a difference as we were hoping for. You can see that they are still not parallel, but because of the huge variance, just from the healthy, you start to appreciate why that is not significantly different with the interaction. You don't need to for this assignment, but you can change the color of that bar. You simply go over to the fill. It defaults to black, but if you'd like to make it a bluish color, like the color of the line, you certainly may. It's not required. Okay, so now I'm going to do the exact same thing for the red. So I've highlighted the red. I'm going to go to add chart elements. I'm going to go to error bars, more error bar options. I'm going to specify a value for custom. These are my positive values. Just highlight those. These are my negative lines here. Hit OK, and it draws more lines. And if you would like, so it's easier to see, you can highlight that. Sorry, that's the wrong one. Can I get to it? There's the red ones. And I'm going to change that to red. There's a lot of overlap with this, so it's a little harder to see. But there you can sort of see the red inside the blue. So that would go on another sheet for your homework assignment. Hopefully this was helpful in seeing how to run a repeated measures analysis, interpret that, and build a graph. Thanks.